Okay, so for sections 1.5 and 1.6, I looked at those. That's just a lot of vocab that everybody can just read through the section and pick up just fine. I didn't see anything really crazy in there. It's all pretty straightforward. So if you have questions on that, let me know. If not, I'm going to assume you can cover that, hit the homework, call it a day. Chapter 2 is where we start doing some baby math, a little bit of math. We're looking at charts and graphs a lot in this section, so I wanted to spend more time there than on chapter 1 stuff. Plus, we only have one day this week, so we're gonna make as best use of our time as we can. I did give you some handouts, so these are directly from the PowerPoint slides on Canvas. Basically, I find it's easier if you have your data set on paper in front of you. If you prefer the digital, that's fine, but this way you can write on these if you want. Makes it a little easier. Okay, so we will get moving. So 2.1 and 2.2 are very related. We are organizing qualitative data. So if you remember, the qualitative data was the description words, more words than numbers. So we often get qualitative data with our different studies. So we do have to have a way to organize it and present it and make sense of it. So the first thing we want to do, once we kind of summarize it, we want to make a frequency distribution. Now, this is assuming we've gone through our data. If it's just simple words, that should be fine. If it's like an open-ended question, you probably want to assign some categories to it, like, hey, this one mentions this one mentions that, and count it that way. We're going to assume it's words for now, just to make life easier. So our frequency distribution is a list of categories of our data. And a count of occurrences. So the data set we're going to look at, I think, is injuries. So we look at how many times does knee injury pop up? So we count those, etc. I forgot to print that one off, so we'll just have to look at that together. It'll be okay. So that's our frequency. It's going to be a table. We have category. And then we have our frequency. That looks weird. Let's put them all together. And it's a table. A lot of times at the bottom of the table, we'll have a total. That's our N, our number of words in our study. A lot of times it's a number of participants, but sometimes, like with our injury data, you can have injuries in more than one place. So you may pop up there twice. In that case, it would be the count of injuries, what have you. So that's our table. Pretty straightforward. Most people have seen something similar, if not this exactly. I'm going to introduce the next two things before we play with our data set, because then we can do them all together. The next thing is a relative frequency. Anytime you see the word relative, it's a percent. So we take our each frequency category and divide it by the total number of the total of our frequency. So I like to say relative frequency equals the frequency of that category over the total number, or the category frequency over our n. I don't think we've talked about sigma notation. Whoops. So your sigma, it is going to pop up a lot in this class. We like our Greek letters. So sigma just means sum up what happens after. So if I say sum f, sum the frequency, add up how many counts we have, how many tally marks, what have you. Later on, we'll sum up some really crazy stuff. Crazy looking, it's really not hard to sum up. But that's what sigma means. So it's going to mean that we're not going to change its meaning throughout the whole semester. That is exactly what that notation is going to mean. Okay, relative frequency is pretty straightforward in finding. Hi, can you shut the door a little bit? Thank you. It's so loud out there. And the last thing I'm going to introduce, I'll introduce one more, and then we'll play with some data, is our bar graphs, or we also call them histograms. I think in the qualitative, we call them bar graphs, and then the quantitative, we call them histograms. It's the same thing. Has anybody not seen a bar graph in their life? Cool. On your horizontal axis, usually you have your categories. So you list them, each one. Your vertical axis should be your counts or your frequency. So how many times does each one of these pop up? If you want to look at your relative frequency, you just replace those with percents. Go usually like 5 to 50%, whatever. Important things to note. Your bars should be approximately the same width. You shouldn't have one bar that's like this and then the other bar is like that. That makes your data look funky and makes people draw the wrong conclusions. So you want things to just be consistent, be tidy. You want to start your count at 0 and go up by the same interval each time. So maybe I want to go up by tens. So this would be 10, 20, 30, 40, 50, whatever. Just make sure each little tick mark has the same number of cases in between. Where people get in trouble is, say we have a lot of counts, like we have thousands. They'll go 0 and then 1,000, 1,010, 1,020. It hurts just to write this. So our first tick mark here, that's 1,000 cases, but each one after only counts for 10 cases. So if you were to draw on this bar graph, you've got some distorted data. It looks like some of your categories are really small when there's only maybe a 10 or 20 count difference. And when we're talking in 1,000, 10 and 20 is pretty small. Relatively, it's small. So don't do that. If you have to put a big gap between your first two bars, your bar graph's probably not the best way to represent this. There's other ways. So the final thing, excuse me, before we practice, is a pie chart. And this has your data as proportions are, or as portions of a pie. This is great for percent data. So a lot of times with our relative frequency, we're going to use a pie chart with that because it fits well. So you see what portion of the pie. I'm going to look at a quick pie chart, but is anyone not familiar with a pie chart? Okay. Most people have seen these, have dealt with them a little bit. I will not ever ask you to make one of these by hand. We have some great statistical programs which will do it. You've got Excel, Google Docs, or Google Sheets will do that. StatCrunch, I'm sure, does that as well. You're going to make a pie chart with one of those tools because it looks nicer and they have pretty colors and all that good stuff. And it's really tedious to do it properly. Okay, where did I hide this picture? Is it here? Okay. So here was our data. I'm not going to have us make this, which is why I didn't print off the data for us. We have, what are our categories of data? Categories of, I'm guessing this is highest education. So we took a survey, we got the frequencies, and you see these frequencies are all pretty high. So maybe a bar graph isn't the way to do this, but a pie chart would be, because we can have percents. So not a high school graduate, they put our relative frequency as a decimal to turn it into a percent, multiply it by 100. So they've got 12% in that first category, 27%. You can read all those down. The last category has about 12% as well. They did the degrees of each measure. I'm not worried about that. But if they were to make it, that's what our pie chart would look like. So this gives you a better picture of what the population looks like than a bar graph would, because we could see proportions. And that's kind of what we're comparing. So again, everyone's seen pie charts before, but it's a common thing. So I figured we'd talk about that. That is for a different section. So is that, what did I forget to print off? Okay. So we have physical therapy data, and this is location of injury. And I'm going to assume each of these injuries could be for more than one person, so you can have a wrist and a back injury. So we're going to count by injury. Can I screw this up? So let's see, how many cases do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9 times 3 are 27 things total. And we would go through and count each one. We're going to do this with some quantitative data. Are we okay skipping this for now? Do you know how we can get there with this one? Just count each one. I forgot to print it. Okay, that is 2.1. Quantitative data displays. Our frequency, relative frequency, histogram, and pie charts are exactly the same. There's nothing different with most of those. The big thing we need to look at is discrete versus continuous. I know last week we talked about the difference in chapter 1, what discrete versus continuous. So for our discrete data, it's going to be sort of like the categories. So grade data, your grade point average for a particular course, you could put in here. If you have wait time rounded to the nearest minute, you could put that in your discrete. Temperature maybe depends on how you want to look at it. So for our discrete data where we have distinct categories, we're mostly going to use a histogram for this. because each bar is its own category that makes sense. With our continuous data, I think that's what we're going to focus on because it's a little trickier. We also we want intervals. Okay, one person doesn't have this. If you look at the page that's just, it says example organizing continuous data. So if you look at that page, it's the one that goes sideways. Let's see if I can pull that up here. Yeah, nope. Okay, so this is the data I handed out in sheets. We can consider this, I mean, technically cents don't have to be continuous, but if we look at our prices, all of our violations here, do you see any numbers that are repeated? At a glance, I do not. There may be some, but I don't see any repeats. So if I were to just do a regular frequency table with this, each of our categories would have exactly one thing in there, and it wouldn't be very useful. So what we have to do is create intervals and kind of categorize them in groups. So go through, you have the page in front of you, you have it up here. What is our smallest value up there, and what is our largest? I'm going to look for largest. Somebody else look for smallest. I see a 210. No, I see a 260. $322. Is there a change with it? How much? Thank you. And the bottom? So that's our range. That's how far our data is spread out. Excuse me. We need to create some intervals that cover all of those numbers. We probably want to have it as whole dollar amounts just because that's a little easier to look at. What do you think? Do you think going up by $10? That's going to give us like 30, almost 30 categories. $20, $50? What do you think? Where do you think we should put that? $32 minus 6. So let's call it 30 difference. 20 is going to give me 15 categories. 50 feels like it's too small or too big. Give me 6 categories. Let's go by 30s, maybe? So how's that sound? Okay, so we're going to create the categories together, and then I'm going to have you do the next part, and I'll pause the video so it's not just dead air on here. So our first category, we need to make sure we're lower than our lowest number, or at least the same as that, and we cover at least our top number as well. Usually we'll go a little beyond. I like nice round dollars, so I'm going to go 60 to maybe 25s would be better. Let's do 25s. So 50 to 74. We need to make sure our intervals don't cross over. So I'm going to go 74.99. My next interval will be 75 to 99.99. So each interval should have the same number of data, or same number of numbers in between, same width, we call it. So if we subtract, we get 24.99 in between each one. Okay, our next one is going to be 100 to 140, right? No, oh, we're going by 25s, aren't we? 125, 50, and 75. Oh, maybe this was too many. 100. We still have a lot to go, don't we? Okay. So maybe 50s would be better. So I go through here. I don't want too many categories. As we're going, I'm going to have more than 10. That feels like a lot. So let's go back and do 50s. Sorry. But a lot of with our stats is going to be a little, not necessarily guesswork, but we're going to have to redo things a few times to figure out what makes the most sense for us. All right. So 50 goes to 99.99. Then 100 to 149. 150, 200, 250, 300, 350, 199.99 to 49.99 to 99.99. So this is our categories. Do you have a question? Yeah, what are those numbers? So we look at the table I gave you. Yeah. What's our smallest number? What's our largest number? So we want to find some data ranges that cover all of our numbers. And so I like to pick, so 65 is our lowest. I like to go up by like 5s, 10s, 50s, something like that. So I figure what's the best thing smaller than 65? 50 sounds like a good start point. And then we go up from there and make sure we go beyond the highest number. Actually, I will not need that last category I wrote down. So we kind of, we made these up ourselves based on what makes the most sense for our data. We don't want too many categories. This feels like a good number. Okay, so I gave you actual papers. So if you want to go through, you can cross these off as you count. We're going to go through and count the frequency of each thing in the data set. If you want to pair up, we have 2 people who are next to each other, 3 people are kind of spread out. That'll help. But I'm going to pause this. Okay, so I went through and counted. I made a mistake, but we found it, I think. And this is what our frequencies should pop up. So numbers less than 100, there's only one of those. Numbers greater than 300, there's only one of those. Then we find we have 17 numbers that land between 100 and 149.99. So count how many occurrences for each one. So that's all we've gone through and done is just count each one. If you can, it helps to like cross them off as you count them. So, you know, you don't miss anything, you don't count anything twice. I didn't do that, which is how I goofed mine. But that's how we make a frequency table. We just count. All right, I'm going to scoot this over. If I want to find the relative frequency, now it's when I definitely get my calculator out. I'm going to take each of these categories, divide it by 50, because we take it divided by the total number of occurrences we have. So 1 divided by 50. 1 over 50 equals 0.02. And I want to turn that into a percent. So I just say 2%. And I know this one is also going to give me 2%. Next category, 17 divided by 50. Oh, these are just double it. Give me 34%. I'm not going to write the percent sign. 34, 18, and 10. So take each category, divide it by 50, and then turn it into a percent times 100. So once we get that, we have our counts. We can either do a bar graph with, or a histogram rather, with the frequency or relative frequency. Personally, I like to use the frequency and save relative for a pie chart, which I'm not making, but you know, it works. So what I'm gonna do, our counts go from 1 to 17. I'm gonna go by fives, I think. 5, 10, 15, no, I'm not gonna go by fives. 2, 4, 6, 8, 10, 12, 14, 16, 7, or 18. So there's my frequency count. And if I want my categories, I'm gonna put the starting number underneath each bar, because if not, that's a really wide thing to write under my bar. If I had a computer to do this, besides just scribbling, I might put the whole thing, put it down sideways, but just putting the starting number is good enough if you have a table with it. So my first bar here is 50, 100, 150, 200, 250, 300. You probably can't see that from far away on the screen, but if you look at the notes later, you should be able to. Couple important things with a bar graph is make sure it's legible, my tiny writing there aside, but make sure we can see the bars. They're not like an eye blinding yellow, neon green, whatever. They're pleasing colors and they don't just mush into one giant bar. So I like to alternate my colors. If I have lots of pencils and pens, do a rainbow, but I'm just gonna do pink and blue, or pink and black rather. So my first category goes up to 1. I'm gonna skip the second one for now. Third one goes to 9. Next one goes to 5. Color these in a bit. Switch to black. This one gives me 17, which is way up here. Oh, 17 as well. And we get 1. So we make a little histogram. I can blow this up a bit now that it's drawn. Yeah, you should be able to see a little better. So we have a bar graph. We can have a visual of our data. It's nice to be able to see our data, but you also want a table telling you what everything is so you can get more exact measures. But this kind of gives you a feel for it. I don't know, pictures help. Pictures are great. The last part of 2.2, even though we'll deal more graphs in a bit, is a dot plot. That sounds funny. Dot plot. It is the exact same thing as a histogram, but we use dots instead of bars. So I'll draw a couple. I'm gonna take the 50 category and the 250 category. 2, 4, 6, 8. So for our first category, we have exactly 1, so we would draw 1 dot. The next category I'm listing, I have 5. So 1, 2, 3, 4, 5. We draw dots for the height. That's really all it is. It's nothing. Honestly, I've seen a lot of statistical studies or studies with stats in them in my day, and I have never seen a dot plot used outside of statistics class. So it's not a common one, but they talk about it, so I figured I'd bring it up. Okay, before I hit 2-3, are there any questions so far? 2-3 is more graphs. Graphs are fun. What do I get for looking away when I'm trying to write? More quantitative displays. There are three we're going to look at here. The first one is our frequency polygon. This is honestly just a histogram, but instead of using bars, we're going to use a line to connect them. So an example, oof, that is very crooked, but that's fine. If we were to have some frequency data, and we're going to put the bar or the dot at the midpoint of each category. So and then we connect the dots. This is great for continuous data because you don't just jump from category to category, it moves. If you have time data, this is also great for time data. But if we can do a histogram, we can do a frequency polygon. So I don't really want to spend crazy time there. We also have something called cumulative frequency. It's a running total. So you're going to add each continuous or each category to the next one. And I'll toss up an example in a second. And with this comes an ogive graph. Maybe it's ogive, I can never tell. This is a line graph with so we're going to start out small. And it's only ever going to increase. You're never going to see it go down because each frequency is higher than the next one, or at most it's the exact same. So it goes up, it goes up, it goes up. Again, that's not a graph I see outside of stats class very often. I can see cases where we would want that, but I don't like it. I said slide 75 and 79. Nope, we're coming back to that. Okay, there's an example of a frequency polygon. Oh, that's our parking data. They use different categories than us, and that's okay. So frequency polygon. 79, which should be my next one. Oh, that's data for it. If we wanted to do the data, we could plot it this way. It's to worry about that right now. The one thing I do want to look at, the other handout I gave you for today is a stem and leaf plot. These are kind of neat once you understand what they're telling you, but at first they just look like gibberish. They just look like nonsense. So this is great if we either have data with some decimals behind it, like a single decimal, or data where we've got like 2-digit or 3-digit data, works great for these. Anything more than that, it gets a little dicey. So for example, I'm going to give us an itty bitty data set, and I'm going to change what I wrote down. That's a 6. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 data values here. If I want to create a stem and leaf plot, we have one number behind the decimal, and then our numbers in front of the decimal, there's 3 different ones, 12, 13, 14. So this lends itself well to a stem and leaf plot. So our stems are the whole numbers before the decimal. So I have 12, 13, and 14. Now, and if we have more categories in our in class example, we will, it'll be longer. Now we're going to go through and figure out what all 12s we have. So I'm going to highlight my 12s. That's you, 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 and you. So I want to spread these out so I can make them all look the same. I get 0.1, so I'm going to write a 1. I have a 2, a 3, and a 3. So if a number is listed twice, you write it twice for its leaf. So if we were to look at this, just the graph, or the chart itself, it tells us we have 12.1, 12.2, 12.3, and 12.3. I'm going to highlight my 13ths. So you, that's it. So 13.1 and 13.5. So now I'm going to write a 1 and a 5. And I want to line up my first numbers and line up my second numbers so we can kind of have like a bar graph that goes sideways. Going to highlight my 14th. So you, and you. I like to put them in order, but we don't have to. So I have a 1, a 2, and a 6. So if we were to take this and turn it to the left, we have a bar graph that's made of numbers. So we can see the height of each one. It's kind of a neat way to present your data. It gives you a picture, but by using the numbers. So it's kind of like a hybrid of the two. I don't know. I always thought they were kind of neat, just weird to understand at first. So what we're going to do is the second handout I gave you, which has the 2 different graphs, we're going to make a stem and leaf plot of this data. So it is slides 63 and 64. We're going to start this together. These are, oh, this is a depressing one. I'm so sorry. Percentage of people living in poverty. How about we change it to percentage of people with puppies? Because that's nicer. Look at our numbers. We have 2-digit with a decimal behind it, so it lends itself well. We can go anywhere from 0, what's our highest number? 13, 15, 19, gross. Okay, so 19 point something is our highest. What's our lowest number? I have a 9, 7. We get lower than 7? Nope. So we want to list each digit between 7 and 19. And even if we have a category with none, we're not going to skip writing it down because that tells us something too. So I'm going to start this 7, 8, 9, 10. Ideally, yours looks neater than mine. Mine's not always very neat. And this is where our decimal would go. Okay. So how many? I have 7.7. Do I have any other 7 numbers? I don't see any. Everyone seeing where I'm finding the 7.7? Should be on the top one, the right side, New Hampshire. Okay. Looking at our data, do we have any numbers that start with 8? I don't see any. Cool, so nothing there. What about numbers that start with 9? I'm gonna go down. I get a 0.6 from Connecticut. I get a 5 from Hawaii. I get a 3 from Maryland. A 5 from Minnesota. Nothing. Oh, I get a 7 from Utah. And that's it. Okay, I again want to pause this so I don't have dead air, but go through and fill in the rest of these. Okay. Didn't miss anything. If I did, it's not the end of the world on this one. I'm gonna guess that was supposed to be a 6. So go through, fill out each category. For 8, we didn't get any, and 18, we also didn't get any. So we don't want to leave those off because nothing tells us something there. And if we did, it would make our numbers look odd and just not flow. So we have empty categories, that's fine. But we can use this in place of a bar graph. So if you look at our data and just don't pay attention to what the right side, the leaf numbers are, you can tell that our 11 and 14 categories have the most, and 7, 8, 17, and 18 all have the least. So you get a feel for your data, but then you can go through and find the exact numbers. If you were to present this in any manner, put them in order. My numbers are all across the board because I was just going as I went. For this, it's fine, but go through and reorder them to go from like 0 to 9. So it looks nicer. But for ours, it's fine. Okay. Are there any questions on these? The last piece of this is 2.4, and it's my favorite thing to rant and rave about. It's my favorite day is bad graph day. We get to look at my files of a bunch of crappy graphs I've found throughout the years. This requires a little bit of participation. We're going to see if we can figure out why these graphs made the file. And they've all made the file for at least one reason. Some of them have made it for several reasons. So things to look out for. 3D. When you should have used so maybe instead of just bars, they used like rectangular prisms. When you use a picture or use something three-dimensional when you should have used two, it makes it look like some of the categories are much bigger than the others. So those two bars, one is double the size. But if I were to make them look like boxes, maybe not on this picture, but now the ones on the right, it looks like the far right is way bigger than the other one. We'll see some better examples. So things like that. Graph or count did not start at 0. It's another big pitfall. If your data is listed in illogical order, and that's going to be different depending on the graph. We'll see a couple of those. It tells you a different story than they are supposed to be telling you. If your graphs are really messy, or there's like a lot of stuff going on, or they're hard to read, that's another reason. There's some other things in here too, but these are some common pitfalls we're going to see. So I'm going to flip this screen so I can see it better. I will zoom these in so we can see them better yet. Hopefully. Okay. Our first one is pretty straightforward. We have ticket prices. So you can see our ticket prices go up by 10. That's fine. What happens is when we have the picture of the balls, instead of just a bar, we've got some weirdness going on. Compare baseball to basketball. Baseball's price is approximately 20. Basketball's price is approximately 40. So double the price. Okay. At a glance, does it look like baseball's price is double based on our picture if we're not looking at the numbers? How much bigger is basketball than baseball? Well, it looks like I can fit 3 or 4 baseballs inside that one basketball. So this makes it look like the difference is a lot bigger than it actually is. So those are the sorts of things we're looking at. And hockey is just a mess. We're going to leave that. Ah, yes, my least favorite graph source. Can you see what's wrong with this one? Hopefully you can read. Some of these are really pixelated. So the graph on the left, the high number there is 35. The one on the right is 39.6. Is that really a big difference? Well, it's a difference of what, 4.6? That's pretty small, but the bars are huge because they didn't start our count at 0. So it makes they're misleading. They're making it look like there's this huge difference when really it's fairly small as these things go. Nope. That's a boring one. No, not you, not yet. All righty, give this one a good look. There's at least 3 things. There's possibly more. I forget how many things we find every year. I really need to get some updated data. This is from 2012. So, is this data presented in a logical order? No, it's not, because we go from 1921 to 1999 to 1934 to 2006. We're bouncing around our years. How should this have been presented? Probably from the first year to the last year, like in year order, right? That makes sense. Why are the graphs or the bars two different colors? And one bar is a different color from the rest. They're not like every other. That's cool. But having one, just it distorts things a little bit. We also have a 3D design where it's like pushed away. So the stuff on the left is smaller than the things on the right. Finally, we don't start at 0. In this case, I probably could have let them go if they didn't count up by 0.5s. So they're making this big distortion when really there's a, what, less than 2-point difference between the first one and the last one. So pitfall. Nope, stop it. The one on the left was what was given on television. The one on the right was somebody else fixing it later, what it should have looked like. So I like this one because we can see what was presented and what should have been presented. You can see that one. A big thing this channel is guilty of is this, and they don't have counts on the right side. Like it doesn't tell you how much each bar is worth, and it should. Same deal. This is aid recipients or something like that. Is a pie chart the best way to present this data? Can you even read this data? I can't. I can tell that we have some words up there, but it turns into a big black mush mess. It's just like a black bar at some point. So a pie chart was probably not the best way to present this because now we can't read it. So it's illegible. I like this one a lot. This one actually has something else going on too. So I'm gonna scroll out. The top 10 most read books in the world. But what is it based on? Based on the number of books printed and sold over the last 50 years. Now, how many of you have bought books that you've never read? Has anybody bought a book that they've never read? I have a pile of them next to my bed right now that I'm going to read eventually. I'm going to end up selling them before I read them. So just because we print a book doesn't mean we've read the book. So they're measuring and claiming two different things. Also, our bars here, if we're looking from the bottom to the top of the bar, which is where we should look, it's very distorted. So we've got 400 is almost the same size as that 27. It's a little bit bigger, but not big enough. I think they're measuring from that line at the top, but that's not clear based on the picture. And finally, can you think of groups who might print the Bible, but not everybody's going to read it? Churches tend to have a lot of Bibles sitting about. Not everybody reads those. I know certain times of the year, there's people handing out little Bibles that people may or may not read. So just because you've printed all of these things doesn't mean people are reading every single one of them. So this is a bad measure, but it's a neat looking chart, so I like it. This is my favorite one. No, not you. You are my favorite. Okay, I'll zoom in a second. We have a Chevy ad. This says more than 98% of all Chevys, Chevy trucks sold in the last 10 years are still on the road. That sounds nice. Yeah, 98% of them. Can you see the bar on the left, the percents? What's our lowest percent there? I realize it's a little hard to read. It's pixelated. It came from a magazine. So it looks to me that we go from 95 to 96, 97, 98, 99, 100. So from the far right category, 95% of those trucks are still on the road. The Chevy, 98%. If we have 100 trucks of each type, that's a 3-truck difference. Is that really all that much? No, it's really not. That's a small amount, but it makes it look huge. Okay, who knows trucks or cars at least a little bit? Brands. What is a big truck brand that's not listed? Anybody know? The big brand that's not here is Dodge. Cars are cars, I don't care, but I know they make a lot of Dodge trucks. I see them all over the place. Why aren't they listed? I'm pretty sure Dodge and Chevy, at least at one time, were big competitors against each other, right? Like you see a bunch of both of those out there. If Chevy doesn't list Dodge, what does that tell you about Dodge's data? If Chevy were better, would they list it? Yeah. If Dodge is better, is Chevy going to list it? No. So the fact that they left out Dodge completely says either their data is just as good as Chevy's or it's probably a little bit better. Now, I'm making an assumption here, mind you, but why else would they leave that off? Why else would they leave one of the big truck companies off of this graphic? Because they're better. For the record, I have a Honda Civic. I don't like trucks, so I don't care. Just pointing out things. That's boring. Oh, no, it's not. That's a good one. No, I already went to you. Oh, this is a newer graph. I really should get some more new ones. Look at the pie chart there. Do those percents add to 100? No, this is not the way to present this data. Your pie slices should add to 100%. Oh, yeah, this one's gross. Okay. Gun deaths in Florida. Sorry, some of these are depressing. Number of murders committed using firearms. So can you have a gun death that's not a murder? Yeah, we'll get depressing for a minute. Suicides could be considered a gun death that's not a murder. Accidents. There's lots of things that could be a gun death that's not considered a murder. So we're claiming one thing and measuring something else. Don't look at the numbers. Based on the graphic, do the deaths go up or do they go down? Looks like the deaths go down, right? Like our numbers climb, our chart climbs, and then it falls. But if you look at it, where's our zero? Our zero is at the top. So actually that big dip around the 2000s, that's a huge increase in deaths. So this is presented upside down. Why would you present this data upside down? That doesn't make any sense. They were trying to lie to you. So look at things like that. I'm like, okay, on its surface, yeah, that looks great, but it should be the other direction. So one thing where was I going with this? So sorry. The screaming red blood color bothers me a bit. So I don't know, color matters on this, and that just is not cool when you're talking about that. So make sure they're presenting what they say they're presenting. This is my last one. No. Okay. This is good old COVID data. We have Georgia. And it looks like from these two graphs, since we have dates, oops, two different dates, I forget when they were from, but it looks like our cases are exactly the same between these two dates, right? The graphs look the same. But if we look at their color-coded chart, they changed their numbers to make the graph look the same. That's bad. Don't do that. So this is, yeah, they're lying to you again. And then this is pointing out how it's different. Boring, meh. Some of these are just boring. I need to delete them. This one's kind of neat. Okay, our last one, registered vehicles. No problem with that. But each of the little graphics represents 9 million. But that semi is the size of 2 trucks, and each truck is the size of 2 cars. So that semi is worth 4 cars. It makes it look like there's a lot more semis on the road than there really are. So if they were to use the little graphics of the cars, I actually don't have a problem with that, but they all need to be the exact same size. So they all need to be as small as that little blue car. Squish them on down. So then you're like measuring dots, not the graphic itself. I have more in here, but those are my favorites. So I'm going to stop that here. And I'm going to stop my video.